We are Team 202, and our project name is CodeSniffer. CodeSniffer is a web application, and as a plagiarism detection tool, its objective is to help faculties, including professors and TAs in universities, to detect code plagiarism in students' homework and their projects. We have three types of end users in our system, which are faculties, students, and system administrators.
Thank you, Hao. This is Anubhuti. I'll brief you about the system functionalities. The aim for us was to build a web application which detects the plagiarism. We had some base expectations and we successfully managed to complete all of those, and we also managed to complete the stretches. The system has an admin which has the functionality to manage users, semesters, and the courses. The system also has a faculty and a students. When the user logs in, he can see a user dashboard where he can select the semester. Once the semester is selected, he can see a list of enrolled courses. Here the dashboard is for a student where he can submit the assignments for a particular course. The student has the option to either upload in the form of a zipped folder, or either he can enter a GitHub URL and submit the assignment. Once this assignment is submitted, the comparison is triggered at the back and the results are stored so that when the professor logs in, he doesn't have to spend time for the comparisons to happen. On the other end, if the user is logged in as a professor, he can see his own dashboard where he can see a list of all enrolled courses. He also has an option to add a course from the existing unregistered courses. He can also create a course and add a new assignment for a particular course. Now, under a particular course, you can see a list of assignments and one of them is highlighted in red. The reason is because inside this assignment, some submissions have a similarity score above the particular threshold specified. Here it's 75. The faculty also has an option to update the threshold and trigger the comparison again. When the professor clicks on a particular assignment, he can see a list of reports, and when he clicks on a particular report, he can see a complete detailed report for two students. Here, the reports are shown for Hao and Anubhuti. The matches for the assignments is 48.2, and the result also shows the individual similarity score, which is 37.84, and for assignment 2, it's somewhere 66. The code In the code, the similar sections are also highlighted in different colors. Here it's in blue, red, and green.
One of the cool stretch goals that we have implemented is the email notification. Again, once two submissions passed the threshold that is set by professor, the system will send an email to the professor indicating the similarity score and also including a URL that leads to the full detailed reports. And here are some of the functionalities that we have achieved for this project. We have covered all the basic expectations and four of the stretch goals. So the first one would be, again, the email notification. And the system also able to compare two languages, which are Java and Python. And students are able to upload their homeworks through GitHub links. And finally, the professors are able to compare these submissions across many previous semesters.
Hi, I'm Sidharth. I'll be talking about the quality of the application. The front end uses jQuery and Bootstrap to provide a simple and intuitive UI. We incorporated all the changes and add-ons suggested by the instructors to improve the usability of the tool. Our main aim was to achieve high test coverage, security, reliability, and readability. The app follows MVC architecture, and the front end and back end were isolated from each other. This helped in making the code modular. Modularity helped us in maintaining and extending the functionalities after each sprint. Code is validated at backend and frontend both. HTTP session was used to implement session management to make the app more secure. We used Java docs for documentation, which helped in readability of the application. Test cases were written using Mockito, and we were able to achieve good test coverage. We used SonarQube to ensure that these quality metrics were achieved. Our application passed the quality gate with grade A in reliability, security, and maintainability. We improved the test coverage with each sprint, and finally we were able to achieve 95.7% of test coverage in the final release, with just 1.6% of the code duplicated. Fibin will introduce you to the process we followed while developing.
Thanks, Sidharth. My name is Fibin, and I will be explaining about the general structure of the process and teamwork. Working with a very supportive team made it very easy for us, each one of us, to complete the tasks on time. The project followed agile methodology with sprints spanning for 2 weeks. In addition to this, daily Slackups and and task management through Jira made the management and planning a lot easier. One particular shortcoming we faced during the initial sprint was lack of proper planning, which resulted in unequal distribution of work. But sprint reviews by TAs throughout the project helped a lot. Right after sprint 1, we started micromanaging the project. We divided the 2-week sprint into 3-day sub-sprints in which each member was accountable for a particular task or a set of tasks. This helped in properly managing the project and supporting the weaker members of the team. This is reflected in the next sprints. Now coming towards the automation part, right from sprint 1 we had set up a pipeline in Jenkins which acted as the continuous integration server. There were 4 stages: build, test, SonarQube, and quality. Each time a pull request is made, all stages are run. Build checks in the protected master branch of Git helped ensure that only quality code, proper test-driven quality code, was pushed into production. In addition to this, SonarQube and quality stages helped remove many of the common mistakes in the code like nested try-catch, use of literals in the project, serialization issues, deletion of unwanted commented out code, etc., which we were earlier ignorant of. Jenkins also helped in automating the deployment of our app to EC2 instance. In effect, the whole DevOps experience was pretty new to the team, but it definitely automated a lot of trivial manual steps in the project. That's all about the process and teammate aspect.
So in terms of technology transfer, our project is currently actively hosted on Amazon AWS servers and is ready to use by the end clients. And we have included the URL in the video description below. So if we would have one more sprint, we would like to achieve the OAuth login functionality, and we would like to compare different sections of the same course, and we would like to invite more outside users to test our UI for more improvements. And because we have implemented our project in a extensible way with modular design and MVC design patterns, it should be very easy for the successors to take our project and keep developing it. And that is all about our CodeSniffer project. Thank you for watching.